we convert oxygen consumption to energy expenditure. Okay, so if we know how many liters of oxygen you're consuming, we multiply it by 5 calories per liter and we convert it to energy expenditure. Okay, so let me give you a sample problem that we ended with. So, and we'll do it together. So if the person's VO2 max was, let's say 45 mLs per kg per minute, calculate energy expenditure for, let's say 30 minutes at 60% of VO2 max, and this is for a person who weighs, let's say, 150 pounds. Okay. If you feel like you already know how to do it, awesome, go do it. Otherwise, I'm gonna write it out for you. So, first thing I'm gonna do is take 60% of this, so we know what number we're working with. So 45 times 0.6 is 27 mLs per kg per minute. So this is the submax VO2, the exercise intensity. So I said there's a max VO2, which is the highest oxygen consumption you can achieve, which is a measurement of your aerobic fitness. You have resting oxygen consumption, and anything in between is submax. So when you're exercising, that's submax VO2. I'm going to convert pounds into kilograms by dividing by 2.2. 68.18 kilograms. Okay, then I'm going to set this up with stoichiometry. 27 milliliters over kilogram minutes. Thousand milliliters in 1 liter. And because I want the milliliters to cancel out, I'm going to put the milliliters down here. Milliliters up there. Kilograms I'm going to put on top so that those will cancel out. Okay, that's going to be the first step, which is going to convert from milliliters per kilogram per minute into liters per minute. Once we have liters per minute, we multiply by the caloric equivalent, 5 calories per liter, which will convert us into calories per minute. And then we multiply by minutes to convert it into calories. So here's what you type into your calculator. 27 divided by 1,000 times 68.18 times 5 times 30. Or you can do all the multiplication and then go back and divide by 1,000. Makes no difference. Bridget?
You said it doesn't matter how it looks on the table of the video, right? As long as we have the right numbers?
Yes, so
Okay.
if you're not comfortable with stoichiometry, you don't have to write it out in stoichiometry, but you do have to keep the units. So you could write it out like this, 27 mLs per kg per minute divided by 1,000 milliliters per liter times the kilogram. You could write it out like this and just show me how your units cancel out.
Okay.
But in order to do that, you have to know whether you're dividing or multiplying. So the cool thing about the stoichiometry is you figure out whether to multiply or divide by your units. We need the milliliters to go away, so I know I'm going to divide. We need the kilograms to go away, so I know I'm going to multiply.
Do you want us to round at all? Or?
2 decimal places at the very end.
Okay.
Yeah, so if you're going to stop after every step, that's fine, but don't round in
Okay,
here at all.
Wait till the end.
Till the end, and then you're going to 2 decimal places. So, you guys couldn't see the ladder that I drew? Okay. Okay, so mLs per kg per minute, we called that relative oxygen consumption or relative VO2. Liters per minute is absolute oxygen consumption. So did you understand the difference between relative and absolute? Absolute being a total number, relative is per something. Okay, so if we're comparing people, it's got to be in relative terms. Calories per minute would be relative energy expenditure, and calories would be absolute energy expenditure. So if the stoichiometry doesn't work for you, you memorize the ladder. How do we get from relative VO2 to absolute VO2? Divide by 1,000 and multiply by kilograms, which is what we just did here. Divide by 1,000, multiply by kilograms. How do we get from absolute VO2 to relative energy expenditure?
Times the torque equivalent
5 calories per liter. And this one would be,
multiplied by 1.
okay, so you can memorize the ladder if you don't like the stoichiometry, and then everything going down the other way is just the opposite.
What's the term attached to kcal per minute?
Calories per minute is relative energy expenditure. This is per minute.
Professor, do we have to put like any units under the kilograms? Because if we just put a 1 because it's obviously the placeholder, but do we have to put any?
There's no unit on that, it's just a 1. You can put a 1 under any number, it doesn't change it.
Yeah.
And then kcal is absolute energy expenditure.
Correct. Okay, so what answer did we get for this? 276?
Wait, 0.13.
0.13, yes?
For 30 minutes.
Calories in 30 minutes at
60% of VO2.
60% VO2 max. That's how I want the unit. Any questions on that? Okay, let me give you these numbers real quick. So, I'm gonna give you average VO2 max numbers. So an average untrained young female might have a VO2 max somewhere around 40 milliliters per kilogram per minute. Average trained young female might have a VO2 max of about 50 milliliters per kilogram per minute. Average untrained young male might have a VO2 max of about 50 mLs per kg per minute. Average trained young male might have a VO2 max of 60 mLs per kg per minute. Okay, it's a good idea for you to have a general idea what a normal number is. So, like when I'm making up questions, when I give you a VO2 max, it's typically somewhere between 35 and 65. Those are typical numbers. Okay, so when you're doing your math, if you do a calculation, you come up with someone having a VO2 max of 125 mLs per kg per minute, that's not a thing. So if you understand what you're doing, you should get that number and say, oh, I must have made a mistake somewhere, and go back and check your work. Or if you get like 1.36 mLs per kg per minute as someone's VO2 max, that's not a thing. So you did something wrong. Okay, is there a question? Okay. So now what I said I was going to do next is make this more practical, make it more usable for you, because I can't tell someone, go out and exercise at 27 mLs per kg per minute. You're not going to have any idea what that means, how to do that. So I'm going to show you how to figure out what speed and grade on the treadmill that is, so you can program for somebody. Okay, so I'm going to give you a formula. This is the ACSM running formula. Do you guys know what ACSM is?
No, it doesn't.
Sports medicine?
Okay, it's the American College of Sports Medicine. So if you've never heard of it before, you will hear about it a lot over the rest of your education, because in kinesiology, that is like our guiding body. They make all of our guidelines, they publish all of our research. It's a really important group that we rely on a lot. So American College of Sports Medicine has these formulas that they developed. There's a running formula, there's a walking formula, there's a cycling formula, and there's a stepping formula that we can use to calculate oxygen consumption at different intensities. Okay, in this class we're just going to be using the running formula, but I posted all of them on Canvas for you, and once you learn how to use the running formula, you'll be able to use them all. And in your labs, If you guys go into the lab and do a submax bike test in the lab, which I know some of the labs are doing, you'll be using the cycling formula for that. So, yes.
Is there no way that, cause I have my lab in online, that I can still go into the lab in person? Like,
You'd have to talk to the lab instructor.
Makes sense.
So the running formula is for anything 5 miles per hour and above. If you're working with something below 5 miles per hour, you're gonna wanna use the walking formula. So this is the ACSM. It literally lasted a day. Maybe it's
Intensity of those.
because of the way I teach. I'm gonna go through these. ACSM running formula. VO2, it will be in milliliters per kilogram per minute. 0.2 times your speed plus 0.9 times your speed times your grade. Grade is the incline on the treadmill. 6.5. You do not need to memorize this. It will be, I'll give it to you on the test. You just need to know how to use it. Okay? So, speed in this formula is not in miles per hour. It's in meters per minute. So you'll need to convert between miles per hour and meters per minute for this. So here's your conversion. 1 mile per hour equals 26.8 meters per minute. Which means whatever the miles per hour is, you multiply it by 26.8 to get meters per minute. And then that's what you plug in here. Grade is the incline on the treadmill. What would be a normal number for that?
3.
3. So the grade on the treadmill usually goes from 0 up to about 12. Some treadmills might go to 15, most go to about 12. That is a percent grade. So if you're at a 3 incline, you're at a 3% grade. If you're at a 5 incline, you're at a 5% grade. So when we put the grade in here, it has to be as a decimal. So 2% grade, what would we plug in for grade? 0.02. Common error here would be to put 0.2, which is a 20% grade, which is not likely to be happening.
It's a steep hill.
Yeah, if you've ever been on a 12 or 15% grade, it's very steep. So treadmills don't go to 20. Okay, so make sure you do that correctly. Okay,
The speed would always need to be over 5 for those? No.
over 5? Oh, 5 miles per hour, yes.
Yeah.
Okay, so this part of the formula is the horizontal component of running. This part of the formula is the vertical component of running. This part of the formula is resting oxygen consumption. 3.5 milliliters per kilogram per minute is resting oxygen consumption. We're going to talk more about that later after the break. Any question?
I was just gonna ask if it was milliliters per kilogram per minute or
Milliliters per
liters.
kilogram per minute.
Can a human body consume 3.5 liters of oxygen at once?
Milliliters.
I know, I'm just asking if a human body, like, if we thought liters, would we automatically know that was wrong because the lungs can't hold that capacity?
That would be like a max.
A max.
So in liters per minute, VO2 max is going to be like 3 to 6 liters per minute max. Yeah.
Okay.
Go ahead.
You said the 3.5 is a resting component?
Resting oxygen consumption. Yeah. Go ahead.
So resting oxygen, that's basically us doing a normal thing. Our body is burning that
Yeah,
much.
it's about what you're breathing right now.
Yeah.
Okay, so there are 3 variables in this formula. The oxygen consumption, the speed, and the grade. Given any 2 of those variables, you should be able to solve for the 3rd. Okay, you should have done some algebra practice with your PLFs, either on the worksheets or in the workshops, where some of it, they should have given you a formula like this that has 3 variables, and you practice solving for the different variables. That was to prepare you for this. Okay, so we're gonna go through it and solve it all the different ways, so you know how to manipulate the formula, and then I'll show you how it's typically used. Okay, so the way it's set up, the easiest thing to do is going to be to give you speed and grade and solve for VO2. So that's how we're going to start. So I'm going to give you a speed of 5.5 miles per hour. And we're going to start with a 0% grade, which is flat ground. That'll be the easiest way to start. so, first thing I'm gonna do is I've gotta convert this miles per hour into meters per minute. How do I do that? Okay, and what does that give me? Please tell me what you got,
147.4.
and that'll be meters per minute. Okay, so 0.2 times 147.4. I don't need you to carry the units through this calculation the way we do on the energy expenditure one. This formula is not set up for stoichiometry for the units to cancel out, so we don't need to hold the units on this. Okay, so that's fine like that. Same 147.4 goes in here, 0 for the grade, plus 3.5. Okay, I suggest as we do this, especially as you're learning it, write out every step. That way, if you end up with something different than I do, we can pinpoint exactly what you did differently. Okay, if I do the 147.4 times 0, I'm going to get 0. And then if I do 0 times 0.9, I'm going to get 0. So anytime we're at a 0 grade, this whole piece just becomes 0. Then I can add those two numbers together. Everybody get that number? Okay, so this is going to be in this is VO2 in milliliters of oxygen per kilogram and body weight per minute. This is VO2. This means that running at 5.5 miles per hour on flat ground requires about 33 milliliters of oxygen per kilogram of body weight per minute for everyone. Okay, this is something that's going to be a little bit difficult for you to wrap your brain around. Every given intensity has a given oxygen requirement. It doesn't matter if you weigh 110 pounds or 190 pounds, running 5.5 miles per hour on flat ground requires 32.98 milliliters of oxygen per kilogram of body weight per minute. So people who weigh more, if we convert this to absolute, will have a larger number in liters per minute. But in relative terms, per kilogram, it's the same for everybody. It's going to feel different to you depending on how high your VO2 max is. Okay, so if your VO2 max is 35 mLs per kg per minute, 5.5 miles per hour is going to feel really difficult for you because it's really close to your max. You probably don't like running very much. If your VO2 max is 60, this is really easy. Okay, but this is the requirement for 5.5 miles per hour. Question?
Can VO2 max be increased over time?
Yes, with training. Yeah, we'll talk about that for sure. Go ahead.
Will we be given the conversion?
Yes, you'll be given
per
the-
hour to- okay.
Okay, questions on this? Yes.
So this is just naturally your body's always gonna have to need this regardless of your weight and everything else, right? Your
Yeah,
body-
this is what is required to run 5.5 miles per hour on flat ground. It's how it feels to you depends on what your max is.
Gotcha.
Okay, so let's keep the 5.5 miles per hour, but we're gonna add, let's add a 3% grade. Can I erase this? Okay, so that 147.4 is gonna stay the same. What am I gonna plug in for grade?
0.03.
0.03. Don't round in between these steps, please. Keep the numbers, write them all the way out. We just need to add all this together. And at the end, we can round to 2 decimal places. wrote out all the steps.
I got 52.778.
Okay, but we need to see your work. You're gonna wanna do it on paper, so that you can separate these steps.
Oh,
Cause we have to do what's inside the parentheses first,
no, I know what I did wrong.
and then,
Yeah.
okay, what's the unit on this?
Milliliters per kilogram per minute.
Okay, so this is the oxygen consumption that's required to run 5.5 miles per hour on a 3% grade. What was it on flat ground? 3298, so that's how much it increased the intensity by adding the grade. Yes?
For the test, you want each step shown, right? Or-
So the more you show your work, the more partial credit I can give you. So if you make one little error somewhere,
You can see that.
I'll take off a point for that error and I'll take off a point for the wrong answer, but I'll give credit for everything you did correct in between. If you don't show me your work, I can't give partial credit. So show me as much work as you. Questions on this? Okay, now I'm gonna give you a VO2 and a speed and we're gonna solve for grade. Can I erase this? Okay, let's do a VO2 of, we're just in the high 30s, so let's do 40.26 mLs per kg per minute. Let's do a speed of 6 miles per hour. And I want you to calculate grade. Okay, if you wanna go ahead and do it on your own, go for it. If you wanna do it with me, I'm gonna do it right now. So this one's gonna be a little bit more complex because we have to move things around the equal sign. Okay, so since grade is the variable we're solving for, I just put the letter G there as my variable. You can use an X if you prefer, or a Y, or you can leave the word grade, whatever works for you. I like to use the G, plus 3.5. Okay, if I do 160.8 times G, I'm gonna have 160.8 G, and then I can multiply that by 0.9. 160.8 times 0.9 is gonna be 144.72 times G. 6.5. Okay, now, these two numbers that don't have a variable attached to them can be moved to the other side. So you can subtract the 32.16 and then subtract the 3.5. You can add both of these together and then subtract. It should all turn out the same. Okay, I'm gonna do minus 32.16 and I'm also gonna do minus 3.5. I'm gonna do that in my calculator. You get 4.7?
Yes. Or,
I typed it in wrong twice, I don't wanna type it. 4.6?
Yeah.
Okay, then I've got 144.72 times G. How do I get the G by itself?
Divide.
I divide both sides by 144.72. This is just gonna cancel out. I'm gonna have G equals 4.6 divided by 144.72. 0.0.
317.
Does that make sense as an answer here?
Do you want it in percent?
I want it
Okay, cool.
3%.
Getting at.
Great.
sorry, if we do the decimal, because I did 3.18%, would that be fine, or do you want it just to round it to the whole number?
So if you do 3.18%, that's fine, but 3.18% you can't do on a treadmill.
Yeah.
So for this, we don't have to be as specific because I want you to be practical. So it should be something you can do on a treadmill.
Okay.
I wouldn't mark that wrong,
But,
but I want you to understand how it applies in real life, what you would put the treadmill on for that.
okay, thank you.
Right.
So say this was 0.039, would you just convert that to 4%?
Yeah.
Okay.
Okay, so this means if we wanna be at 40.26 mLs per kg per minute, and we wanna run 6 miles per hour, we need to put the treadmill at a 3% grade. Why might we wanna be at 40.26 mLs per kg per minute? Maybe that's 70% of our VO2 max. So that's our goal of where we want our VO2 to be, and we're calculating speed and grip. Good? Okay, now I'm going to give you a VO2 and a grade, and we'll solve for speed. Erase this. Okay, let's do a VO2 of, I'm gonna go pretty high here to make sure I have space to have a speed and a grade. So I want a 3%. Let's see if we can get to a 4% grade. So we need to calculate speed in miles per hour. So plug 44 in for the VO2. Speed is the variable I'm solving for. I'm just gonna leave an S there. You can use whatever letter you want. If I multiply the S times the 0.04, I get 0.04S, and then I can multiply that by the 0.9. Right. Okay, I can move to 3.5 to the other side. And then if I have 0.2 bananas and you have 0.036 bananas, we can add those together. So I'm gonna get 0.236S. What do we do to get the S by itself? Divide by 0.236.
Like this is the,
Does this mean we need to run 171 miles per hour?
No,
No,
you need to divide.
This is meters per minute. How do we convert it to miles per hour? 26.8. 6.40 miles per hour.
units are gonna be crucial in this one.
You what?
Units are gonna be crucial.
And you have to understand what you're doing, so you don't just stop at the 161, that's my answer. You have to think, I'm looking for speed, it needs to be miles per hour, I'm not done. Yes?
Sorry, the question that you asked before, when you said, are we running 176, was it miles per hour?
Miles per hour.
What unit is that in?
This is meters per minute,
Right, okay.
so we divide it by the 26.8 to convert it. Yes?
For the final answer, for miles per hour, is it okay if you do M over H? Like M
Yes.
plus H?
Any other questions on this?
So for the equations, we need to do it in liters per minute, but in the final answer, you want it.
Yeah, I'm
in
gonna want your,
miles per hour.
if I give you a speed, it's gonna be in miles per hour, and if I ask you for a speed, I'm gonna want it in miles per hour.
Okay.
If you left the answer like this, if I didn't specify, sometimes I forget to specify, tell me speed in miles per hour. If you leave it like this, it's fine as long as you put a unit on it, meters per minute.
Okay.
But if you just left it like this without a unit, I just mark it off. But if you put 171.61 meters per minute, that would be fine. Unless I specified miles per hour, in which case that wouldn't be correct. But if I forget to specify miles per hour, please convert it to miles per hour, because that's what I meant to ask for. Go ahead.
If we don't put units throughout the calculations, is that fine?
Yeah, I don't want units to do this calculation. It's not gonna work.
It's only-
They're not gonna cancel out the way they do in the energy expenditure. All right, so we played around with this formula. We solved it all 3 different ways. So now I'm gonna show you how you're most likely to actually use it. Okay, I'm gonna erase this. Is that okay? Okay. I'm just gonna do my- All right, I'm gonna take Charlie.
Slow.
Charlie's gonna hire me as his trainer. I'm gonna take him out to the track. I'm gonna have him do a 1.5 mile run as fast as he can. I'm gonna take his time. I'm gonna plug it into the formula that I was given in my 346 lab, and I'm gonna calculate his estimated VO2 max. Okay? Let's say Charlie's VO2 max comes out to be 58.16. What does that number mean to you? What are your thoughts about his fitness? This is a high number. Okay, Charlie's very fit.
Man, thank you, I appreciate that.
Okay. As his trainer, I'm gonna work him really hard, and I'm gonna say he needs to work at 80% of his VO2 max. That's what I'm prescribing for him. Calculate what speed on the treadmill he needs to be at with a 0% grade, just on flat ground. How fast should he run to be at the intensity I want him at? Okay, so you're given a VO2 max, so please don't plug in the 58 mLs to that formula, because he's not going to be exercising at his max. He's going to be exercising at 80% of his max. So you take 80% of that number, plug that into the running formula with the 0% grade, and figure out what speed he needs to run at. Okay, go ahead and do that on your own. Everybody get what I got? Anybody stuck? Okay, so So we can't put the treadmill at 8.03. So we can either put it at 8 or we can put it at 8.1. Okay, since it's 0.03, I'm just gonna put it at 8.1. We can do that on the treadmill. Miles per hour. Okay, so I know that if I put him on the treadmill at 8.1 miles per hour, he's gonna be at 80% of his VO2 max, which is where I want him training. No, you have a question?
So, do we have to round it up to make it applicable for the treadmill?
Yes, that's what I'd like you to do.
So
Okay.
always round.
Give me a number that you can actually put on the treadmill.
Okay.
Okay, Charlie, how do you feel about this speed?
A little rough.
Yeah. So he's gonna come back to me and he's gonna say, oh, hell no, I'm not running at 8 miles per hour. I refuse to run faster than 6.
Yeah,
But now we gotta-
How do I adjust this to get him to this intensity?
adjust the grade.
Increase the grade. So I still want him at 80% of his max, which is 46.53, but he's gonna be at a speed of 6 miles per hour. Figure out what grade he needs to be at to achieve this intensity. Everybody get what I got? Anybody stuck, confused?
Can we do 7.53?
You can, but 7.53 you can't do on a treadmill. So the closest is 7.5. So on the other calculations, I want you going out 2 decimal places, but for something like this, that's, we're actually trying to put it on a treadmill, I prefer you make it usable.
If we put it at 8, would we get it wrong? We rounded it
Yes.
Yeah.
So when Charlie's on the treadmill at 6 miles per hour, ask him if he cares if you put it at 7.5% grade or 8. Guarantee he cares.
Gotcha.
Okay, yes.
I noticed on the last one that you put, when it was 0.03, you rounded it up to 8.1. On the last, problem, it was like 8.03 and then you rounded it up to 8.1. So if we were to round this one up to, like 7.6.
So you could have rounded that down to 8.
Yeah,
Yeah.
I could have, I was mentioning that
I think
you
I did round, it was 8.03 and I rounded it down to 8.
You
Nine?
did 8.1.
No,
No, you did 8.1.
yeah,
That's
so I
why I
was,
got confused by this.
yeah,
Oh,
that's why I was asking
you were
too,
just
so
more hard.
like if you want like 7.6.
I'm just crying over here.
I thought it was like 8.5 or.
Oh, yeah.
Move it up to 8.1.
that sounds like my mistake.
Okay, so if it's 8.4 and below, 8.0 would be the answer.
So basically just stick with the closest rounding,
Yeah.
don't go up.
Yeah.
Okay,
The closest rounding that you can actually do on the treadmill.
okay, cool, yeah, okay.
Okay, so I tested Charlie's VO2 max. I decided as his trainer what percent of his VO2 max I want him at. And I told him what speed and grade to be at on the treadmill so I can be very specific about his intensity. We okay with that so far? Now, if he does this for 30 minutes, how many calories will he burn? Calculate energy expenditure if he exercises at this intensity for 30 minutes. We need a weight, so I'm gonna do 175 pounds.
Would that be the absolute, would that be the,
Well, because I'm giving you minutes, you'll be able to go all the way to calories, yeah. If I didn't give you minutes, you wouldn't be able to go all the way to the top.
okay.
Okay, see if you can do this on your own. I'm just gonna hold off a minute before I start writing it. If you need to wait for me, that's fine.
Oh, sorry. I guess the reason I was confused is I didn't know if it was, relative or absolute because you did give us the minutes, like 30 per minute, or is that we just go all the way?
Yeah, so if I give you, you need the minutes to get here.
Okay,
So if I give you the minutes, you can go all the way here.
okay.
If I don't give you the minutes, you'd be stuck
You
here.
have to figure out the minutes and then you can go.
Yeah, or your answer would be
Or
calories per
the,
minute.
okay, unless you specifically asked for them, okay.
Let me know when you get an answer. I'm sorry?
555.22.
Anybody else get that? Still working.
I teach chem.
This is your moment to shine.
Huh?
This is your moment to shine.
Yeah. It's my moment.
Anybody else get that number? Anybody getting something different?
Are you gonna have margin of error for these questions?
Yeah, for sure.
You just get like 200.
Usually if it's in like one whole number,
Yeah.
it's fine.
Okay. See, you're
But you
Maybe year one. Maybe year two doesn't have.
Don't even start with me.
We have to.
I got the nice calculator.
maybe you're saying you figure it out.
Don't question that as our leader. I'm gonna get your answer here and be like,
Did everybody get this number? Okay, what's the unit on this? In 30 minutes
80% yield to
at 80% CO2 max.
Wait, did you get that on your calculator? See? Thank you. Go ahead.
reassuring to the professor.
Yeah.
Everybody okay with this? Okay, so now, I did a VO2 max test on him. I decided what intensity I want him at as a trainer. I tell him exactly what speed and grade to run at to be at that intensity, and I can calculate how many calories he's gonna burn. Phenomenal tool. If you ever wanna train somebody, you can really control their results with this. So people who are personal trainers who just get a certification don't learn how to do this. You're learning to do this because you're getting a degree. So this takes you from being a $30 an hour personal trainer to being a $75 an hour personal trainer. You know how to do this. So I take kickbacks. Pretty cool stuff. Questions on any of this?
Is there any way you could write us the equation for like the first way we got to this, like, you know, the mile that he did a 1.5 mile run and then his time gets us the equation?
Do you have a lab manual?
No.
You don't have a lab manual. It's in your lab manual.
Our class was supposed to be in person, and they changed it the first day of
No, we
classes,
got the
so,
lab manual.
and we were like, what?
I didn't get it.
It's a big PDF. I have the whole PDF of the lab.
Of the lab manual? Okay, maybe you can share.
Well, there you go.
The formulas are all in that book. But they're also really easy to look up. It's the Cooper 1.5 mile run. You can literally just Google that and pull up the formula. And there's a Rockport walking test, there's a 12-minute run test, there's a step test. Yeah. All right, let's take a 5-minute break. And